So as I mentioned, the classic example of a checked exception is exceptions related to input and output. So let's just back up a little bit and talk a little bit about reading input from text files and writing output to text files. So we can actually use the scanner class to read from a file. It's very easy to use. You should be pretty used to using the scanner class to read from the keyboard. And you basically have all those same methods available to you to read from an input file as opposed to reading from a keyboard. So instead of sending the keyboard as input when we create our scanner object, we instead send a file object. So we would create a scanner object, I'll call it file scan. It's a new scanner, but instead of sending keyboard.in, what I do is I send a new file reader object. And to create that file reader object, I send a new file. And to create that file, I send as a parameter the name of the file in quotes. So this might look a little bit convoluted, but it's just the way that we can use the scanner object. This wouldn't be code I would expect you to memorize. You can just always do a quick lookup of how to use scanner to read from a file. But if we do this, our file scan object now has all of the methods available to us that we are used to from the scanner class. So next line, next int, any of those methods. And another common thing to do is actually create additional scanner objects to process the text within that file. So if our file scan object now is reading input from our file, let's say line by line, and let's say that file was comma separated, we can actually create another scanner object, and that scanner object will process a single line of code, a single line of text, and we can use a method called useDelimiter where we specify a delimiter, for example, a comma, and that scanner will process that line dividing at the commas. Okay, so when we use linereader.next, it'll give us all the code, the text rather, sorry, up until the comma. So let's just look at a quick example of that in a moment. Okay, so before we do that, let's just look at our checked exception. So one type of checked exception is IO exception. So IO exception is a class. It inherits down that on the left side of the tree of checked exception. So it eventually inherits from throwable. And a lot of our operations that are performed during input and output might throw this kind of exception, an IO exception. So for example, if we try to read from or write to a file that doesn't exist, that's going to be an exception that inherits from IO exception. If a file exists but the program can't find it, if a file doesn't contain the type of data, all of these things might generate exceptions that are inherited from IO exceptions. And all of the IO exception classes are checked, meaning we either have to catch them or we have to propagate them and tell the compiler that we're propagating them. So writing output to text files, we can use a series again, kind of like we created our scanner object through a couple of calls to a couple different constructors. We can do the same thing to write output to files. We want to use a print stream object because print stream has the same print and print line methods that we're used to that system.out does. But to use a print stream object, we have to use a combination of a file writer, buffered writer, and print stream objects. So it looks like this. So if this was the name of our output file, output.txt, we'd create a new file writer sending in that file name. Then we'd create a new buffered writer sending in the file writer. Then we'd create a new print writer sending in the buffered writer. Okay, so just like we had a couple of nested objects to create our scanner, we'll use that same couple of nested objects to create our print writer. And again, you don't have to memorize that. You can always just do a quick lookup. Then we can just use print lines on our outFile object. All right, that should be a capital F. To print whatever we want to print to our file. Very important though, we always have to close our file. If you are writing to a file and it does not close with Java, it will not, whatever you've written will be gone. It will not save it. Okay, so whenever you're using a print writer to print, you have to make sure you have that file closed. That's an example of something we always want to put inside a finally block because we always want to make sure that we've closed. So even if we've written half our file and an exception happens, we still want to make sure that file gets closed so that that first half gets saved. Okay, so let's just look at an example. It's a lot easier to see how to use these things if we do so with an example. So what we're going to do is we're first going to do some input. So we're going to read some comma separated data in from a file. So you'll see what I mean about using two different scanner objects. And first we're going to quote ignore the exceptions that might happen. We can't really ignore them because they're checked, but we're just gonna, I'll show you what it means to kind of not deal with them. And then we'll figure out how we want to actually handle them. Okay, so I have my, here I'm going to do some input. So I have the code written so we can just trace through it. And this is what the input data file looks like. So it's 3 comma separated values, Jane comma Smith comma 1 2 3, John comma Doe comma 4 5 7, and Sam comma Stein comma 5 5 5. So we have a first name comma last name comma and an ID. A quick note, if you are using Eclipse and you want input and output data, the files go one level up from your source folder. So this is the name of my project folder, San Mateo lecture, and here I have my source folder where all my .java files are, and I have my bin folder where all my .class files are. My input and output text goes one level up from that, so it goes in the same folder as your source and bin. Okay, there's my input data. Okay, so if you're using a different development environment, the location of your input and output files might be different. But if you're using Eclipse, this is where they go. They go one level up. Okay. So here what I'm going to do is I'm going to create a scanner object from a file object. And to that file object, I send the name of my text file. So I put a string containing the name of my file. I use that to create a file object. And I use that to create a scanner object. Okay, this is again how I do file input using scanner. And then I'm going to have a while loop that's just going to loop as long as scan has something else to read. So as long as there is more stuff to be read inside my file, I want to keep looping and reading from that file. Okay, so I have a while loop. As long as scanner has more stuff to read, I'm going to keep looping and reading. And then inside my while loop, I just read a single line from the file using nextLine. Just like I would use nextLine to read from the keyboard, I can use nextLine to read from the file. So one line from my file, I just get it with scanner. And then I'm going to create a second scanner object called lineScan. And what I'm going to send to that scanner is my single line of text. So one line would read this, for example, Jane Smith 1 2 3. That's going to be stored in one line. And now I create a second scanner object called lineScan, and I send this Jane Smith 1 2 3 line of text in as my parameter. And then I say that that lineScan object is going to use the delimiter of a comma. What this means is that I can use the next method to loop over anything that's divided by a comma. So linescan.next is going to give me Jane, and then linescan.next again is going to give me Smith, and then linescan.next again is going to give me 1 2 3. Okay, so that's how we use a combination of two scanner objects. That's a pretty common thing to do when you're reading in data, especially if it's comma separated data. We use one scanner to get a full line of text from the file. We use a second scanner to parse that line of text using whatever delimiter we say. So this could be a different delimiter other than a comma. The comma is the most common. And then we use that second scanner to parse over the pieces of that line. Okay, and in this example, we're just going to print out the results. Last name, comma, first name, and ID in parentheses. Okay, so let me first comment out my exception handling. And you will see that I have an error. And my error, let's see. I'm missing. Okay. Oh, I'm missing, I thought my while, that's why. Okay, so you will see that I now have an error in my program, and the error happens here, and it says I have an unhandled exception type, file not found exception. So I am not able to compile this program because I'm trying to do file input. File input might generate what's called a file not found exception. That is an exception that inherits from IO exception, and that's a checked exception. And right now, with this code commented out, I'm not handling it, and I am not able to compile because of that. So that's the difference between unchecked and checked, right? Before, it might have been bad practice not to deal with my unchecked exceptions, but I could still do it. Here, with a checked exception, I can't even compile it. I can't compile my code at all. Okay, so if it's a checked exception, I have to deal with it. And there are two ways I can deal with it. I can either put it inside a try catch block. So that's like this. That's my first option, and we'll look at the second option in a moment. Okay, so here's my first option, putting it inside a try catch block. So now when I run this code, right now it did not find the data because I misspelled the input data, left out the U. So this line of code was attempted to be executed, and then exactly what happened, our trace is going to be the same as if it was an unchecked exception, right? An exception was generated, exception was thrown. Java said, okay, what's the type? The type of exception is file not found. I look for a handler in the method I'm in. I go down to my catch blocks. I find one. It's right here. I print out, I execute the code. In this case, this was just printing out the message, which was the system cannot find the file specified. And then if there was, here, I'll put another line here so we can see. There's code down there, it would continue to execute. Okay? So the trace is exactly the same, whether it's checked or unchecked. What happens to the exception once it's thrown, totally the same between checked and unchecked. The only difference is the code that you have to put in before you can compile. So again, this is a checked exception is thrown. We catch it here. Notice that none of this code happens, which makes sense, especially for this kind of exception, right? How can we process the file if we couldn't even find it? So once the exception is thrown, the try block is done. We jump down to the catch, execute the appropriate catch, and then pick up with anything after. Okay? If, of course, we had the right file name and we run this, no exception's ever going to be thrown, and this would process just fine. It would print out last name, comma, first, followed by the ID for all 3 lines of our code, and then it would print the code after the try catch. Okay? So this is an example of, first of all, doing file input using 2 scanners to parse data, comma separated data, and also putting a checked exception inside a try catch. Now, let's say we had a second method where this code was happening. Okay, so here we have our input happening in our helper method. So if we run this and no exception happens, it's basically going to be the same thing I just ran. But let's say that now we decide that instead of handling the exception in helper, it makes sense to propagate it back up to main. Okay, so let's say we don't want to, just like with an unchecked exception, we could do that. We could say I don't want to handle my exception here. I want to handle it somewhere else. We can still do that with checked exceptions. So let's get rid of the exception handling here. And we'll put it up here. Okay, so here I'm saying, okay, I want to try to invoke my helper method, but I know that my helper method might throw this kind of exception, and so I want to handle it here inside main. But the problem is, because this is checked, I have to do one extra step, because you'll notice that I'm still getting that same compile error. Oh, unhandled exception of this checked type. So because it's a checked exception, I have to add a throws clause to my method header and tell Java, oh, this kind of exception might be thrown and propagated from this method and handled somewhere else. And once I do that, my compiler error goes away. So because it's a checked exception, I have to say, I'm going to not handle it here. I'm going to handle it up here in my previous invoking method, my next level up. But I have to tell Java that's what I've decided. Because otherwise, Java is going to think, oh, you're just trying to ignore that checked exception in this method, and you're not allowed to do that. So I have to tell it, I'm not ignoring it. I recognize it might happen. I'm going to handle it somewhere else. And if I didn't have this handler code here, I again would get a compiler error, right? Because Java is now saying, uh-oh, this line of code might throw a file not found exception. That's a checked exception, and you haven't handled it. I'm going to give you a compiler error. So actually, if we decided we really didn't want to have a try catch at all, and we just kind of wanted our program to crash, we can actually add a throws clause to our main method, which means it will crash the program. I do not advise doing this. This is a way yes, your code will compile and it will run, but this is really bad practice, okay? If there's a checked exception of something that, like a file not found, some other sort of IO exception, you really should handle it in it with a try catch, okay? So this is an example again of our inputting from a file and then using checked exceptions. And again, you have one of two options. You can either catch them or you can propagate them. But if you propagate them, you have to put the throws clause inside your method header.